These are examples of parent functions, and the parent functions we are considering here are exponential function and trigonometric function. So when you look at this, I consider these examples with their reflections on x-axis. Okay, students should understand that there is distinct difference between reflection on x-axis and reflection on y-axis. And what that means is that suppose you have y equals f of x. Okay, so when you have y to be minus f of x, this is what we call reflection on x-axis. If you have y to be minus f of x, and this is what we call reflection on y-axis. Okay, but the examples we are considering here are reflection on x-axis. So let's start from the given function. The first one, which is exponential x, y to the exponential x. So the first thing to sketch the graph of this, students need to know the domain of the function, the range of the function, the x-intercept if possible, and y-intercept. So these are the 4 key points students need to understand before sketching a given function. Okay, for domain of this function is set of real numbers, and this can be written as this. Okay, and the range here is f of x greater than 0. That is the range of this particular function, because there is no way you can get negative value for y irrespective of the value of x. Okay, so now we consider x-intercept. Okay, x-intercept, there is no x-intercept here. Why? Because for x-intercept, that implies that y must be 0. When it points in on x-axis, that point y must be 0 at the point. So, and for the case of this function, y can never be 0, so which implies that there is no y-intercept here. And for that reason, y equals 0, x equals to 0 is the asymptote, but we are not going there in this tutorial. Okay, so what of x-intercepts? What of y-intercepts? So there is y-intercept here. Y-intercept occurs when x is equals to 0. Alright, so when x is equals to 0, what will happen to the given function? This is exponential 0 and this is 1. So which implies that y-intercept here is 0, 1. Mind you, I told you there is no x-intercept here. There is no x-intercept here. Why? Because for you to get x-intercept, y must be 0. And which implies that when you substitute y to be 0 in the given function, which is 0 equals exponential x, this is not possible. There is no such value of x that will make this function to be 0. That is what you are saying here. So by implication, we only have y-intercepts for exponential x. So we use these 3 parameters now to sketch exponential x. Okay, so let's consider graph for that. Okay, so let's say this point is 1, so and that would be 0, 1. Okay, okay, so this is the graph for exponential x. So, and one amazing thing about this function is that this x-axis is asymptotes, so this curve here approaches x-axis. So when you continue sketching this curve, this particular curve approaches x-axis, but it never touches what? X-axis. That's the meaning. Okay, now let's consider the reflection on x-axis. Okay, if this is exponential x now, so we consider exponential minus x. Okay, y equals minus exponential x rather. So I told you, whenever you have something like this is reflection on x-axis, which implies that the curve we have here, you know, the first one here is above x-axis, so for its reflection, and that will be below x-axis. and this is what that means. So you are going to have something like this. This is what you are going to have, and this point now we are now going to have new y-intercept here, and the new y-intercept here is -1. Okay, and that is a graph of exponential x. Okay, so we consider the second question, which is ln x, ln x or ln x. So it's same thing as natural log actually. So y equals ln x. Okay, so it starts from domain as well, domain of this function. So domain, I told you in the last tutorial video that domain is a set of inputs. Okay, what are the possible inputs this function can take? That's the meaning. So domain here is x greater than 0. So ln function can never take negative. When you put negative inside this place, this will give us math error using your calculator. Okay, so natural log cannot take negative results. Okay, so that is why the domain is x greater than 0. All right, so the range here is set of real numbers, and that can be written as this. Okay, so we can actually get different results for y. Okay, now next thing I told you is that we consider whether you can have x-intercept in the function or y-intercept. So for us to have x-intercepts, what happens at x-intercepts? Y must be 0. Okay, we check this now. Can y be 0 here? So when y is 0, what will happen to the function? That means you have ln x equals 0, and this will give you exponential 0, which is 1. So which implies that x-intercept here is 1, 0. Okay, then is there y-intercept here? Is there y-intercept here? For us to have y-intercept, don't forget x must be 0. And remember from the domain here, I told you that x is greater than 0, which implies that x cannot even be 0. So that is why you cannot have y-intercept here. Okay, so we use the range, domain, and x-intercept to get the graph of this. Okay, so let's consider this. Okay, so we have so this is the graph of ln x. This is the graph of ln x, and this point here is 1, which is 1, 0, which is the x-intercept. Okay, so now let's consider reflection of this as well. Okay, so what you have here, we reflect on x-axis, talking about y equals minus ln x. Y equals minus ln x. So for that one, meaning that where you're supposed to have positive here, you will obtain negative in this function, and where you're supposed to have negative there, you have positive in the new function. Okay, so which implies that when this curve now reflects on x-axis, student is going to have something like this. Okay, so this curve also approaches y to be 0, x to be 0. Okay, so and this is 1 as well. Okay, so that is the curves for ln x and minus ln x. So let's consider one of these three functions that we have here. Okay, which is sine x and minus sine x. That was number 3. Okay, y equals sine x. Okay, for this sine, the domain for sine is set of real numbers. Actually, the domain is set of real numbers. For the case of this tutorial, I will only consider the domain to be from 0 degrees to 360 degrees, and of course this is equivalent to 0 less or equals to x less or equals to 2 pi. So one is in degrees and the other one is in radians. Okay, so this is the domain for sine x. All right, why the range? Range here is -1 less than or equals to f of x less than or equals to 1. And for x-intercepts, so these are the x-intercepts we have. Okay, let me sketch that, then students should send comments on x-intercepts using this curve below. Okay, so you have this. Sorry, this is cos. This correct? No. Okay, let's try to do something better. Good. So this is the graph for sine x. Now, it is important for students to indicate the maximum of the curve, which is 1, and minimum here is -1. So sine function, sine x can never be greater than 1, and the result can never be less than -1. Sine x generally. Okay, and this point here is 90 degrees. This is 270 degrees. Why this point here is 360 degrees. This is 180 degrees. Okay, that's for sine x. You can see now, so that means you have 3x intercepts here, 90 2 x intercepts, 180 and 360, except you want to consider the origin as well. Okay, so the reflection of that on x-axis, now. So the only thing that changes here is the maximum and minimum. Okay, the maximum and minimum. And of course, if you look at the one we have at the left hand side here, it is obvious here that the graph here starts from the center, then to the maximum. But what happens to the curve when it reflects on x-axis? That means that we go from center to minimum, then to maximum. Okay, so this is what we are going to have. This is not perfect, but then so that means this is 1 and this is -1. Can you see that now? So when that reflects on x-axis, that's what you are going to have for minus sine x. Okay, same thing applicable to cos x. So sine and cos have the same domain. For cos x, domain here is set of real numbers. Okay, but in the course of this sketching the curve, I will only consider numbers from 0 to 360 degrees. Okay, and range as well. Range here is from -1 to 1. That is the range for cos x. Okay, so the difference here is that the difference between sine and cos is just that cos starts from the maximum while sine starts from the midline. Okay, so this is the graph of cos x. Okay, where this point here is 1, this is -1, and the intercept here, this is 90 degrees, this point here is 270 degrees. So I stopped here because I only consider 0 to 360 degrees. So this point here is 360 degrees. I can have more than this actually, if we are to consider the set of real numbers. Okay, if you are not limiting the domain to be 360 degrees. This is what I'm saying. We are going to have something like this. To continue like this. Okay, so because we only consider the domain from 0 degrees to 360 degrees, that's why we have something like this. So reflection of that now. So the reflection of cos x, so we start from minimum, then you have this. Okay, So this point here is -1 and this is 1. So this is y equals minus cos x, y this is y equals cos x. Okay, you can see the graph is very important in the sense that what this implies that, let me start from cos x. At this point here, that means when x is 0, cos 0 will give you 1. That's the meaning. When x is 90 degrees, cos 90 degrees is 0. And this point here is what's it called, is 180. So when x is 180, cos 180 is -1. You can use calculator to confirm that. And likewise, when x is 270, cos 270 is 0. When x is 360, cos 360 is 1. You can see that. Then the same case applicable to minus cos x. Then let's move to sin x. Okay, sin here is when x is 0, sin 0 is also 0. So when x is 90 degrees, sin 90 degrees is 1. When x is 180, sin 180 is 0. When x is 270, sin 270 is -1. So the process continues like that. Alright, so the next one is tan x. Okay, let me leave that one for you. So try that, look for the domain, the range, x-intercept if possible, y-intercept, and drop that at the comment section. So don't forget to like, subscribe, and share. Thank you.